How are you, my friends? This is lecture number 33 of the pre-calculus course about algebra of matrices. For other lectures, please, you can see the playlist down here. Now, the objectives in this lecture will be the equality. We will define when two matrices are equal. How do we add and subtract matrices? Also, how do we multiply? And we will look at some properties of matrix multiplication. Equality of matrices. Two matrices are equal if they have the same dimension, m by n. You remember m is the number of rows, n is the number of columns. And the second condition, their corresponding entries are equal. So we can see here the first example. These are equal because we have 18, 18, minus 7, minus 7, minus 3, minus 3, 45, 45. These are equal. This one is not equal. These matrices are not equal, although we have the same numbers, minus 5, minus 5, minus 2, minus 2, 20. We have here 20, but not in the same location. That's the reason here. And 9 here, equal to 9, but not in the same location. We should have 9 here and 9 there. These are not equal because they have not the same, they don't have the same dimension. Let's look at example 1. If the matrices are equal, find the value of xy divided by t. So we have a matrix, the first one 2 by 2, and this is 2 by 2, same dimension. These numbers are equal in the same location, 2x minus 1 is equal to y, etc. Then we can find the value of x, the value of y, and the value of t. So what can we do? An easy way, just put them equal because it's given they are equal. So I take each entry is equal to the entry or the element or the member or the number in the same location. So 2x minus 1 is equal y there. Y minus 7 is equal 5x plus 1. 3 is equal to 3 for sure. T plus 8 is equal to 2t minus 4. We can see that this is a linear system. So we can use any method we like to solve it, find x and y. So I can use substitution method. So I take y here, 2x minus 1, replace it in the second equation. I get 2x minus 1 minus 7 is equal 5x plus 1. Rearrange the equation. So 3x will be minus 9 divided by 3x will be minus 3. So to find y, go back to equation 1 or equation 2. Equation 1 is easier. Replace x by minus 3, you get minus 7. So we have x minus 3, y minus 7, and also to find t, we said, remember, t plus 8 is equal to t minus 4, so t will be 12. So we can multiply now xy over t, that's the expression we need. Minus 3 times minus 7 divided by 12, that will be 7 over 4. Matrix addition now and subtraction. If the matrices have the same dimension, sometimes we say same order, sometimes we say same size, but the best word is to say same dimension. Then we can add or subtract corresponding entries, remember. So we have this one, minus 1, 7, 3, 8. And here we have 30, minus 1, 2, and minus 6. This is 2 by 2. This is 2 by 2. So we can add. How do we add? We add or subtract the corresponding entries, the entries or elements in the same location. So minus 1 and 30, that's 29. 7 you add to minus 1, that will be 6. 3 you add to 2, that will be 5. 8 and add minus 6, it will be 2. Now remember, the addition and subtraction the same way. Multiplication is not the same way. When you multiply matrices, we will see later in this lecture, the method is completely different. Note here we have the sum of difference of two matrices of different dimension is undefined. So if we have a matrix 2 by 2 and the other one 3 by 3, we cannot add. We say the addition is undefined. Just to know that, please. Let's see, find the sum of all entries of the matrix H. H is equal to this one plus this one minus this one plus this one. Can we add here and subtract? We have to check. See, the first one here, H is all this. This is row 1, row 2, row 3. So this is 3 by 1, the dimension. This one 3 by 1, this one 3 by 1, this one 3 by 1. Yes, we can add. You have to check first the same dimension, remember? So to add, here I said first check the dimension. Yes, 3 by 1, then we can add. So we add, and here remember we subtract. There's a minus there. So minus the 0, minus 9, and minus 11. So when you add, you will get here altogether, H will be 13, 7, and minus 12. The question says find the sum of all entries. So we add 13, 7, minus 12. The answer will be 8. Let's see. Given a matrix here 2 by 2, and this is 2 by 2 plus this one is equal to this one. That means we have to add first, then we make them equal. And then we need to find x squared plus y squared. So what can we do? So here are the steps. Add the matrices first, check the dimension. Yes, each one is 2 by 2. Equate, make them equal. So I can add here 2x plus 3y. I write it here. That's one entry in the first row, first column. 4 plus minus 2, that will be 2. Minus 3, you add to minus 2, that will be minus 5. 5x minus y equals this one. So you have to check. This 2 is equal to this 2. For sure, you have to have that. Minus 5 is equal to minus 5 in this location. So we can take the first element here, in the first row, first column. 2x plus 3y is equal to minus 5. And this one, a2, 2 will be 5x minus y is equal to 13. That's a system now, linear system. You can use any method to find the variables x and y. See the idea here? So let's use elimination. Elimination, I choose equation 2 because we have here minus y. I multiply by 3, the whole equation. See, the equation 1 stays the same, 2x plus 3y is equal to minus 5. This one multiply by 3, multiply by 3, multiply by 3. I get this one. When I add, I cancel the y. Remember, you have to multiply 13 by 3. You have to multiply 5. You have to multiply minus y also. So we get 17x plus 0y is equal to 34. Just divide by 17, you get x equals 2. So go back to equation 2 because it's easier. Put x equals 2, y will be minus 3. So now this is x will be 2. We square it because the question said find x squared plus y squared. You square the x, you square the y, and the answer is 13. This is a scalar multiplication before we take the multiplication of matrices. Scalar means a real number. We can multiply any matrix by a real number. Scalar. So this is like, look at this example here. 2 times this is 2 by 2. So you multiply each entry or each element by the scalar. So this is a scalar here. It can be positive or negative or fraction. So you want to multiply 2 times 3, that will be 6. 2 times minus 1 will be minus 2. 5 times 2 is 10. And this one, 2 times 0 is 0. Now this is 10 times this one. This is the 3 rows, 1 column. So 3 by 1. Multiply 10 times this, 10 times that, 10 times this. You get 13, 2, and minus 90. So remember this, we call it a scalar. Now we have 3 properties of matrix addition and scalar multiplication. If we have A plus B, remember capital A, capital B, and capital C are matrices. Small c is a scalar, which is a real number. So we have A plus B is equal to B plus A. When you add matrices, they are commutative. That means we can add A plus B and B plus A, the same answer. A plus B plus C, or A plus B first plus C. This is associative property. And this is multiplication. You multiply scalar C times A plus B. You can say small c times A plus small c times B. That will be correct property. Let's see two questions in example for A and B. One by one. Let's say find the product of entries on column 2 of the matrix W. So what is W? This is W. The scalar 3 times 2 by 2 plus 2 by 2. So what do we have to do? Just from the question here, we can add the matrices first. We get 2 by 2 for sure. Then we multiply by scalar 3. Then we need the product of the entries, all the elements. Remember the entries, all the elements on column 2. That's in the question. And then we can look at B after that. Let's see W first. So first we add the matrices here. Remember, minus 2, 11, when you add, you get 9. 0 minus 1, you get minus 1. 5 and minus 8, you get minus 3. 1 and 7, you get 8. Now multiply by 3. That will be 27 minus 3 minus 9, 24. What do we need? Find the product of all the entries on column 2. This is column 1 here. This is column 2. This is row 1, and this is row 2. So minus 3 times 24 will be minus 72. This is the answer for part A. Let's go back a little, please, and see B part. Find the sum of entries on the main diagonal of the matrix R. What is R? All this is R. Please, you can try it. I advise you before you see the answer. But I can help you here. You multiply the scalar 2 by this, and then you subtract this matrix here. Then you multiply the 5 times, this is a scalar 5 times this. Then you add. When you finish, you get R. Then find the sum on the main diagonal. The main diagonal means this one here, guys, like 11 and 2, 1 and minus 6, 1, 1. After you finish, you will get one answer R. So the main diagonal is this. Always the main diagonal starts with A11 and we go diagonal. This is the main diagonal. Let's see R. You can check. Did you get a 41, please? Check here. Multiply by 2. So that would be 22, 6 minus 8, 4. See, there's a minus here. Either you subtract directly, or you can change this minus to a plus. And then you include the minus here, minus 1, in each element like you multiply scalar. So it becomes minus 1, minus 7, minus 5, and 6. See? See, when you have a subtraction, two choices you have, please. Be careful about that. Either you subtract, it's up to you. Either you subtract, or some people, they like this way, which is easy. Change it to addition, and then include the minus inside. This is like multiplying scalar by minus 1. And this one will be 5, 0, 0, 5. Then I can add now easily. You see, 22 plus minus 1 plus 5. So that will be 26. And then 6 plus minus 7 plus 0. That will be minus 1. And then so on until I get R. This is R. Let's see the sum on the main diagonal. This is the main diagonal here. You see, guys? Let's look here at question number 5. Given the matrices A, 1 minus 2, 0, 3, and B is there 2 by 2 also, Let's find the sum of all the entries on the main diagonal of a matrix T satisfying the equation 3t plus a is equal to b. This is an easy question, just to practice on the addition and subtraction. Move a on the other side. Easily we can say 3t plus a is equal to b. We can move a on the other side. So we have b minus a. This is subtraction of two matrices the same dimension. So we can subtract normal. Minus 3 minus 1 will be minus 4. 4 minus minus 2 will be 6, etc. Then we have to multiply by the scalar 1 over 3. We don't say divide by 3. We say multiply by 1 over 3, because this one we have to multiply by 1 over 3. So we get t. So you multiply by 1 over 3 scalar. So it will be minus 4 over 3. Multiply each entry here by 1 over 3. So the capital T becomes minus 4 over 3, 2. 2 over 3 minus 2 over 3. What do we need? The sum of the entries on the main diagonal. So the main diagonal, remember, minus 4 over 3 plus minus 2 over 3, which is minus 6 over 3. The LCD is the same 3 here. So the answer is minus 2. Now we have reached the matrix multiplication. There is only one condition. Please be careful to multiply two matrices. We have A and B. The dimension of A is, let's say, m by n, and the dimension of B is n by p. This n here, you see this n and this n, they must match. They should be the same equal numbers. Again, so if we have A, m by n, B, n by p, we don't care about m or p. We care about these numbers here. If these numbers the same, yes, we can multiply AB, and then the answer here, the result, has a dimension m by p. Now, again in English, to multiply two matrices, the number of columns here of the first matrix should be equal, see that English, should be equal to the number of rows here of the second matrix. That's the only condition. And then the answer will be m by p. These m and p can be the same as n or different. We don't care. Let's look at done example 2 by 2, easy. So I have here 2 minus 4 minus 3, 7. That's, let's say this is like A. And 6, 5 minus 10, 3. Now to multiply, be careful. Don't do a big mistake. Don't multiply 2 times the 6. We don't multiply entry by entry. Remember. See, the first element here is 52. The first entry is 52. How do we get that? We multiply row by column. So this is A11. That's the element in the first row, first column. So I multiply whole row by the column here. So 2 times the 6 plus minus 4 times the minus 10. All of this is the element. 2 times 6, that's 12. And then 40. When you add, 52 is the element here. Same thing, we go A12. See the location here. First row, second column. So 2 minus 4 row, multiply by the column here, all the column. 2 times the 5 minus 4 times the 3. Just add these two. Now second one here, A21, second row, first column. So minus 3, 7, we multiply by 6 minus 10. So minus 3 times 6, that's minus 18. 7 times minus 10 minus 70, so minus 88. And then here we get 6. This is the way we multiply. Now the rest will be examples. You can practice and understand. Okay, now these are properties. If we have A times BC matrices, or we can say AB times C, that's associative, it's okay. A multiplied by B plus C, it should be from the left side, AB plus AC. If you multiply from the right side, B plus C, A, it will be BA plus CA. Now remember here, example 7 shows that even when both A and BA are defined, you can find sometimes AB and BA, but they can be different or the same. Most of the time they are different. This proves that the matrix multiplication is not commutative. So we can say in general, AB not equal to BA. Let's see that. This is example 6. Suppose A is 3 by 2 matrix, while B is 2 by 4. Can the product AB be calculated? If yes, find the dimension. This is simple question as introduction. Can the product BA be calculated? If yes, find its dimension. So let's look at AB. It's better to write like this. You see, it's better to write AB in order. Write A 3 by 2. Write it down in front of your eyes. B is 2 by 4. Compare these two. They must match. Yes, so this is, they must match, they are equal, yes. So we can find AB. The answer will be, the dimension will be 3 by 4. Now, let's look at BA. Write down B. See the same B here, 2 by 4. Write A, 3 by 2. These different, they are not matching. Then we can say that BA is undefined or cannot be calculated. Example number 7 is really nice because it shows you that if we have M and N 2 by 2, we can find the product Mn, see here, it's 2 by 2, and then we can find Nm, but they are not the same. I will show you now here. Find the product of the entries on the main diagonal of this matrix. So we have to find the product Mn, then find the product Nm, subtract. And if they are different, there will be an answer 2 by 2. Then we find the product of the entries on the main diagonal of the result. Let's see. Mn, oh, easy. I put here M. This is the same as the done example. You can review that. 2 minus 5, 0, 7, 3, 1, 2 minus 1. And here we have Nm. See, it's easy to multiply now. Row, remember row by column. So that would be minus 4 there. 6 minus 10. And then row by column. You have to go slowly now. Then you take 0, 7, row by column. You get 14. Same thing you do here. Now we know that Mn is not equal to Nm. Now the first 2 by 2 will be Nm. So it's minus 4, 7, 14 minus 7, minus. This one, Nm, it will be 6 minus 8, 4 minus 17. You subtract, minus 4 minus 6 will be minus 10. 7 minus 8 will be 15. 14 minus 4 is 10. Minus 7 minus 17 will be 10. What do we need? The product on the main diagonal. So we multiply minus 10 and 10 will be minus 100. Please, if you want to review how to multiply, go back to the done example, please. Let's see example 8, more and more examples. E is what? Row 1, row 2, row 3. So this is 3 by 2. This is 2 by 2F. Find the sum of all entries in the last row of the product EF. So let's try to find the product EF. Then we take the last row and then we add the entries. Easy. Check first, please. E is 3 by 2. And check dimension, remember here? Check the dimension. E is 3 by 2 and the F is 2 by 2. So when you multiply a row, see here, row by column. I put all the details for you. Row by column. So minus 1, minus 3, 3, 3. This is another done example, you can say. All right, and then row by column here, minus 1, 2, and then 3 and 1. Check please all these numbers. And then the row here, 4, minus 2 by column. So 4 minus 3, minus 2 and 3. Then 4 and 2, minus 2 and 1. Then the last one here, row by the column. So 5 minus 3, 0, 3. And then row by the column, 5 times 2, 0 times 1. Now we get EF, that's the product here. 12, 1, minus 18, 6, minus 15, 10. What do we need? Find the sum of the entries in the last row. So I take minus 15, row 3, and 10. When you add, you get minus 5. Another nice example, given the matrices E and F, if possible, find the product FE. See, in example 8, I think same numbers here. In example 8, we found EF. In example 9, we try to find FE. Check the dimensions. The F here is 2 by 2, you see? E, 3 by 2. These numbers, they are not matching. See, 2 and 3, they are not the same. Green numbers here, they are not the same. Since the colored numbers are not the same, stop. We cannot find FE. FE is not possible or undefined, or we cannot find the product. Let's see more and more. If the product is possible here, check if we can multiply these two matrices, then find the sum of all entries of the result. Check, can we multiply these? Possible or not possible? You have to check the dimension, please. You can pause the video for a little, check it yourself, and then you can see the answer if you like, please. Let's see. 3 minus 4, 2. If you are ready, let's go now to the solution. So before multiplying, check the dimensions. The first one, row, row, row. See? 3 by 1. And this one row here, but 3 columns. So the first one, 3 by 1. The second one, 1 by 3. Can we multiply? Are the colored numbers here, the inside numbers, are they matching? Yes, they're matching. Look at the result now. When you multiply, the result will be 3 by 3. Big matrix. So I put here the same numbers, 3 minus 4, 2, 5, 6 minus 1. This is only checking before you multiply. You have to check. Now let's multiply row by column. 15 there, you see? Easy. Row by column, 3 times 6, 18. Row by column, minus 3. Continue these stars. There are 9 more numbers. Then you answer the question. The question is what? Find the sum of all entries of the result. Okay, let's see. When you continue multiplying, you will get, you can use these colors, nice colors actually. 15, 18 minus 3, minus 20, minus 24, 4, 10, 12, minus 2. Add all the entries. So I add 15, 18 minus 3, and then minus 20, minus 24, 4, 10, 12. The answer is 10. Check it, please. Let's look at example 11 here. We have 3 matrices Y, 2 by 2, as you can see. D is 1 row here, 1 by 3, and A, 1, 2, 3 rows, 3 by 2. Let's find the product of the entries, all the entries of the matrix day. So we have to multiply D times A times Y. We will get day. Let's see, first, as usual, please, we have to check the dimensions. So this is D, 1 by 3, and this is A, 3 by 2, and this is Y, 2 by 2. See, these numbers should match. They are matching, yes, 3 and 3. And these numbers, they should match. 2 and 2, they match. So the result will be 1 by 2. So I put here day, this is D, and this is A, and this is Y. So I multiply row, here, see row by column. Minus 7 times 0, 3 times 1, 2 times minus 4. When I add, I get minus 5. Check it. Now row by column again. Minus 7 times 1, 3 times minus 2, 2 times 5, that will be minus 3. Now I multiply row here. This is dA, and this is the Y here. So I multiply row by column. Minus 5 times minus 2, minus 3 times 6. I add, I get minus 8. And here I multiply row by column, I get 3. Find the product of all entries. We have only 2 entries. We multiply them, we get minus 24. So remember here, the result is 1 by 2. 1 row, 2 columns. That's day. Now in this lecture 33, I will leave 2 parts for you to practice. Part 1 has 5 questions with the answers. And then part 2 has 6 questions with the answers. Now let's see part 1. Part 1 has 5 questions. This is question A and B. Question 1, A and B. Find all this matrix D. Remember here there's an inverse. If you know how to find the inverse, A times A inverse, or when you multiply A times A inverse will be the identity. The inverse will be coming next lecture. Here we have to find CD minus DC. C is 2 by 2. D is also 2 by 2. Find that one. Number 3, find the matrix X satisfying 3x plus a squared is equal to B. Think about that, please. And then here we have to find the values of x and y if a minus b all squared is equal E minus 3i. Remember, I is the identity matrix for 2 by 2, which is 1, 0, 0, 1. That's easy. We call it identity. Question number 5, we have matrix X, matrix Y, matrix Z. Find the matrix M, which is XY minus half Z. Nice to try. Now, when you finish, these are the answers only if you want to check the answers. 1, 2, 3, 4, 5. For complete solutions, please, of all these questions, you can see Algebra of Matrices in the playlist Extra Pre-Calculus Solved Questions. Another part 2 will be 6 questions there. This is C and D. Find CD, find DC. The dimensions are different. You can check, please. We call this all the exams question number 1. All the exam question number 2. Find the W here if we can. All the exam question number 3 is a nice one. Given the matrix A, 2 by 2, find the sum of all entries of the matrix 2A squared. Think about that, please. And then B part, find the matrix 2A squared plus A. See what will happen there. Number 4, find the product if possible. Check and see the examples in the lecture 33 to compare, please. Question number 5 is a true false. I have 3 parts here. A, B is equal BA, A minus B. These are all matrices. Times A plus B is equal A squared minus B squared. The last one here, check if this is true and false and see the solution, please. All the exam question number 6, we have A and B, and we have to find the matrix X such that 3A plus 5X is equal 3X plus B. Think about that and compare it with one of the examples. And these are the answers of the 6 questions. For complete solution, please, of these questions, you can see Algebra of Matrices, Lecture 33, Pre-Calculus, Old Exams questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is a Pre-Calculus course, Lecture 33. I wish I can see you in another video with another topic. Thank you for listening.